Welcome to SQL learning session. Today we'll be talking about union, minus, and intersect from database for developers. In this lesson, there are 12 sections and we'll go through each of them. The first section is introduction. Let's go through it. The set operators union, intersect, and minus allows you to combine many tables into one. This tutorial will use two tables for the queries. My bricks and your brick collections. And these are the data in these two tables. The my brick has around five rows and three columns, and your brick has five columns and three rows. Second section, union. Union operator combines two or more tables into a single result set. To use it, table must have same number of columns with matching data type in each position. Brick collections table have different columns, so combining these two with select star leads to an error. Now let's try to combine these two and let's see what we get. You get an error because the count of columns are different and columns names are different. To resolve this issue, we have to select the common columns between these two tables. This is how to do it. We select color and shape from my brick and color shape from your brick collections. And once you do that, we'll get a result that we need, the union. The union is a distinct set of operations. Third section, distinct. There are two red cubes in a table, one in each table, but union only displays one. This is because union applies distinct operator to your result. This discards duplicate rows, so your result will only have one row for each set of column values. You can use distinct by placing it after select and before the column list. This squashes out duplicates, so you only get one row for each set of values in your columns. For example, there are two green parameters in my collection. If you do distinct, you get only one copy of brick. Here you go. Let me do it once more. My brick collection. I'm going to do this because such that we want to see what's the difference between these two. And there you go. Here we have a two green parameter, but you get only one green parameter in a second set because of distinct. You can use distinct on a subset of table columns. For example, to get one row for each shape in your collection, select distinct shape. If you do this, then you get a two sets of two values for shape. Now let's see how many values are there in first place for this column. You have a cuboid, but once you do distinct, you get cube and cuboid. Union of section 4. Often, when combining tables, you want to see all rows, including duplicates, not the distinct values only. You can do this by union now. Here's the example. Here, we are doing combining two tables, my brick and your brick collections, with union now, and this preserves all the values without removing the duplicates. This is similar to using this. If you do the standard union, if you need to union, it is similar to doing union all. You'll get a same result. Doing union all and distinct from is same as doing union between these two SQL queries. it's going to be same result. Now, this thing operator adds extra sorting to your SQL. So in most cases, you'll want to use union all. Save plain union when you want to know, you want to remove the duplicates. Section 5. This is an exercise where we need to write a query to return a list of all colors in two tables. Each color must appear only once. Here's a partially filled query. Now, looking at this query, can you tell me what needs to be done to get the result we want? Let me show you. We are asked to write a query to return all the lists of the colors in two tables. All the colors. And each color must appear only once. This is a restriction. Appear only once. So that means we need the distinct values of the colors. Therefore, we'll use union without all, and this should give us the distinct values of the colors. Let's try this, and this is exactly what we get. Secondly, we need to write a query to return list of all the chefs in both tables. There must show one row for each row in source tables. That means the duplicate value must show, and it should not be deduped. How do you do this? Here's a partially filled query, and this is the result we need. Can you tell me, looking at this query, what needs to be done to get the result we need? Let me show you. Here, we need to preserve the source rows. That means we need to union all between these two queries. Once we do this, we should get the result we need. Let's run this. And this is exactly what we need. Section 6. Set difference. Difference between the set difference operation returns all the rows in one table, not in another. You can do this with not exist. When you do this, this returns all the rows in one table, that's not in another. Here we do the connected subquery, where subquery is connected through some joins. And what happens is that if there are many columns that needs to be joined, it becomes quite confusing. And it introduces lots of bugs later. And the one problem with this is it handles null incorrectly. Suppose, let's say if shape has null and null values in both tables, null will never be equal to null. Therefore, we need to add additional clause to take care of null. And this is how we do it. Here, we have shape, it has a null value, and if it is a null, then we have put a clause here to handle for null values. And it should give us result what we need. Now, if you run this query, it will return you a null value because it is not handling the null properly. This color is null, and since color but this value already exists in my bricks. If you look at this value already exists there. But null is not equal to null, because of such, it will show up there. 7. Section 7, minus. Oracle database includes an operator that implements set difference called minus. It's easier to use than not exist. All you need to do is select the relevant column from each table with minus between them. The set operators are one of the rare cases where database considers null value to be equal. So the following query returns same rows as not exist with null checking. This is similar to this one. Now if I put this one here and if I put this one here, it should give us a similar result. or same result, in fact. There you go. Section 8, finding common values. You can find values that are in both tables with exist. As with not exist, due to this correctly, you need to test null for subquery. And we are checking such that both tables exist, same value exists in both tables. The benefit of using exist is that it doesn't implement distinct condition. If you don't want distinct, then you have to use this. But if you want distinct, then you have to use the intersect between those two tables. The set operators such as distinct, minus, union all implement a distinct function within them. Now if I do this, it will check the rows that are both common in both tables. This operator calls common values in a set function called intersect. You can use the same way as union and minus. Let's that between two queries. Now let me place this between two queries such that we can see what's going on here. We get the same result. As with minus, database considers null values to be equal and applies a distinct operator to result. One thing here to keep in mind is intersect also removes the duplicates. Even though in this case, it is producing the same result, but if you do intersect, it will distinct the result set before it gives it to you. Try it. Number section. Here's an exercise we need to do now. Here, we need to write a query to return a list of all shapes in my collection and not in your collection. Here's a partially filled query. Looking at this query, can you tell me what needs to be done to get the result we need? Let me show you. We are being asked to write a query to return a list of all colors that are in both tables. All colors. Now, if you do intersect here, then it should get the result we need. Here, it doesn't say you have to preserve the source rows. If they're duplicates, you don't need to mention duplicates. You can remove the duplicates. That's why we will just use intersect because it's a lot easier than writing the exist. Intersect. Now, second way to write this is select shape from my bricks where exist. Select one from your brick collection. Let's say M where Y. Let's name this as Y. Let's name this as Y, and let's Y equal to it has to be same shape, right? Shape equal to M shape. It needs to happen like this. Command properly not ended. Where exist. Let's do this. Let's see what we get. Select shape from my M where exists. Now it's coming. Can you see the difference between two? If you do exist, it does not remove the duplicate, but if you do intersect, it removes the duplicate and shows you the result. Section 11. Finding difference between two tables. Symmetric difference. You can combine set operators to implement a classic use case. Comparing two tables, return a list of all values that only exist in one table. This is known as a symmetric difference. There isn't a native operator that does this, but you can do it by finding rows in one table, not in the table 2, minus finding row in the table 2, not in table 1 with minus, combining output of these two with union all operator. My collection has a blue keyboard and two greens pyramid that is not in yours. And you have a blue cube and I don't. So these two should appear in output. But when you do chain the operators as described below, you will get not a desired result as we need. These are not all the symmetric difference values that exist between two data sets. This is because the set operator all have the same priority in Oracle database. To fix this and do the minuses before union, you need parentheses as we have done before in the where class. Yeah, we'll fix this using the parentheses. First of all, we'll do minus. We'll do two data set and do select from. Secondly, we'll do union all. We'll do union all and do select from second data set. Once you do that, we should get a result we need. These are values that are exist only in one table, either in table A or table B, but they don't exist in both tables. This is called symmetric difference, a classic use case. This is not the only way to do it. You can do create or calculate symmetric difference by combining all rows from two tables into a using union all. Then finding the intersect that's common between those two and doing minus between first to second. Here's a query that has been implemented with that prescription or method. First of all, we are doing unioning all the tables and we are minusing the values that are common in both tables. And once we do that, we should get result what we need. Section 12, symmetric difference with group by. There's a drawback in the process we did just now. The problem is that if the tables are large, when we read the same table twice, we are spending lots of time just reading the tables. And it makes a query a long time to execute. To make it much faster or to optimize the query, you can do the group by. First, you have to read all the rows. Now, we can do this, we can solve this using a group by. Here, this is a query, what I was talking about. In this query, we have a subquery where we put two additional columns, your brick and my brick. If I'm querying your brick, then your brick will be 1, my brick will be 0. If I'm querying from my brick will be 1 and your brick will be 0. And we combine those two doing union all. Then we group by, then we do it as a subquery and we group by color and shape. Once we do color and shape, we sum the your brick and my brick and select those color and shape that have your brick is not equal to my brick, which will show us the color and shape which have some discrepancies. It will not tell you how many discrepancies, but it gives us a color and shape which have some problems or which are not equal. But there are other benefits of this method too. It enables you to see which table has more rows. or more bricks, in this case, more color shapes quantity. You can calculate it. And you can also see how many values are more. Here's the example. Here, we did same thing as before. And in outer query, what we are doing is when your brick is less than my brick, I say for this color shape, I have more bricks. And it calculates by how many. And if they're equal, then there's no problem. It's a zero. In this way, it not only helps you to see the difference, but also calculates how many are, what's the difference. And that's the benefit of this query. In the end, let me quickly summarize what we learned today. We learned about union, we learned about distinct, we learned about union all, we learned about differences, we learned about minus, and we learned about finding common values. We learned about intersect. We learned about how we can use exist and not exist to set the differences and common values. The difference between minus and intersect and using exist and not exist is that minus intersect have will always have the, the distinct built in, but exist and not exist don't have distinct built in. And we learn about how we can calculate symmetric differences using just set operators and using group by as well, which is much cleaner and faster and much more versatile. So that's all for today. I'll see you next learning session. Thank you so much.